Number 2. Let's see what's going on. They tell you that, well, two-way. They tell you that vector u is 1, 0, 0. Vector v, well, vector u sub, was that u1? Vector u1 is that. Vector u2 is 0, 1, 0. And vector v is ABC, which is 6, 1, 3. And let's see what they want. They want P, the plane, to be z equals 0. That's just the xy plane. It doesn't go up any. It doesn't go down any. But what I do want to do is I want to go up. So one moment, please. Let's copy this. Let's delete it next. Let's delete it and paste it on the top. Okay. Now they want us in part A to compute the projection of vector v onto P. Well, the projection of vector v onto the plane V by definition is v dot u1 over u1 dot u1. That's a scalar times the vector u1 plus v dot u2 over u2 dot u2 times the vector u sub 2. Okay. Now, here is vector v. Here is vector u1. And we want to dot them. You multiply across and you add up the numbers. 6 plus 0 plus 0 is 6. So the numerator is 6. Now, what is u1 dot u1? I'm going to erase this, and I'm going to put u1 in here. That's u1 dotted with u1 again. 1 times 1 is 1. u1 is this, excuse me. 1 times 1 is 1. 0 times 0 is 0. 0 times 0 is 0. You add them, you get 1. Times vector u1, where vector u1 is 1, 0, 0. Now we do v2 dot u2. v2 dot u2. v dot u2. This is v dotted with u2, which is 0, 1, 0. Multiply, get 0. Multiply, get 1. Multiply, get 0. So we get 1 plus 1 over. Now we do u dot u2. Well, I already have u down there. I'm going to write it down again. u2 dot u2. 0 times 0 is 0, plus 1 times 1 is 1, plus 0 times 0 is 0, I get 1. 1 over 1 times u2, which is 0, 1, 0. Okay, let's get this out of the way. 6 over 1 is 6 times 1, 0, 0, plus 1 over 1 is 1 times 0, 1, 0. So now we're almost done. Multiply each of those entries by 6. 6 times 1, 6 times 0, 6 times 0. Plus, multiply each of those entries by 1. 1 times 0, 1 times 1, 1 times 0. Now add component-wise, because it says add. Add the first components, add the second components, add the third components. 6 plus 0 is 6, 0 plus 1 is 1, 0 plus 0 is 0. And that is your answer for Part A. Now there is Part B. Part B, I think, if I remember right, that's the one that has 3 different parts to it. Yep. So, U2, so this is B1. They tell you that U2 is, I take that back, they tell us that U1 is 1, negative 1, 0. And they want you to find U2. What goes there? Now, they want U2 to be in the plane x plus y plus z equals 0. Remember, that's x, that's y, and that's z. And when you add them, you do get 0. Okay, so that point is on this plane, x plus y plus z equals 0. Okay. Now, the first entry can be whatever you want. The second entry can be whatever you want. But the third one has a problem, because we want it to add up to 0. So it has to be negative a plus b. So now, you want U2, not only the b on this plane, that is not only for x plus y plus z to equal 0, but also you want it to be, you want U2 to be orthogonal to U1. So 1, so that means that the dot product of U1 and the dot product of U2, it must be 0. 1 times a is a. 1 times, negative 1 times b is negative b. So plus negative b or negative b. And this is 0. That is a minus b. But you want this to be 0, because only 2 vectors are orthogonal. That means they meet at right angles if and only if the dot product is 0. Well, if a minus b is 0, that means a must be b. Okay, so let's update U2. It's a, b. Well, a is a, b is also a, and minus, well, a plus b, well, that's a plus a. That's 2a. Any vector in this form, 2 things happen. When you add up x, y, and z, you get 0, and it's orthogonal to U1. That is negative 1, negative 1, 0. So if we let a equal 1, we get 1, 1, negative 2. That is what we're going to call U2. You could have picked any other number other than 0 for A. You could have let A equal pi. You could have let A equal negative a half. A could have been negative 1. I picked the simplest one. A is 1. Okay, so I think I finished part I. B sub I. Yeah. Okay, so now for part B, B sub 2, they say vector V is equal to ABC, which is A, B, C. A is 5, B is 0, Z is 2. Okay, and U2 is 1, 1, negative 2, and U sub 1 was given, and that was 1, negative 1, 0. Now, they want you to compute the projection of V onto the plane. The projection of V onto the plane. Well, we have the formula. It's V dot U1 over U1 dot U1 times the vector U1 plus, do the same with U2. V dot U2 over U2 dot U2 times U2. Okay. So V dot U1. V, I'm getting all my values from here. V is 502 and U1 is 1, negative 1, 0. Multiply across, I get 5. Multiply across, I get 0. Multiply across, I get 0. So this numerator is 5. Now I do U1 dot U1. I'm writing down U1 here, and here I already had it. Well, multiply the 1's, get 1, plus multiply the negative 1's, get 1, multiply the 0's, get 0, so I get 2. 5 over 2 times the vector U1, 1, negative 1, 0, plus. Now we're going to compute V dot U2. V dot U2. V is still 502, and U2 is 1, negative 1, negative 2. Multiply, get 5. Multiply, get 0. Multiply, get negative 4. You add those up, you get 1. So the numerator is 1. And now what we want to do is U2 dotted with U2. And U2 is 1, 1, negative 2. Okay, so there might be a problem there, because actually there won't be, but let us compute V dot U2 again, please. V is 502, and U2 is 1, 1, negative 2. 5 times 1 is 5. Now here I had negative 1, but it didn't matter because I multiplied it by 0. But now I have the right value, and that's negative 4. That adds up to 1, which is what I have, which is good. Now we're going to do U2 dot U2. Why? One simple reason. That's what they're asking for. U2 dot U2. U2 is 1, 1, negative 2. dotted with itself. 1, 1, negative 2. So you get 1 plus 1 plus 4, which is 6, times U2. 1, 1, negative 2. So now I multiply 5 halves by each of those numbers. 5 halves times 1 is 5 halves. 5 halves times negative 1 is negative 5 halves. 5 halves times 0 is 0. Plus, now I multiply 1/6 by each of those numbers. I get 1/6, 1/6, and I'll keep this as negative 2/6. The common, so it's going to be 5 halves plus a 6, negative 5 halves plus a 6, and I didn't realize that was 0. I will reduce that. 6 of times negative 2 is negative 1/3. Minus a third. Okay, so 5 over 2 and 1/6. I want to write it with 12 on the bottom. If I multiply this by 6, I get 12. I have to multiply the top by 6. I multiply this by 2, I get 12. I have to multiply the 1 by the 2. So now, if I add these two, 5 halves plus 1/6, I get the same as adding those two, which is 32 over 12. Divide the top by 4, divide the bottom by 4. So, looks like 8/3. Now, this one is negative 5 halves. So it's negative 32 over excuse me. So if I add these two, I get negative 28 over 12, which is negative, 4 goes into the top 7 times, negative 7 times, and into the bottom 3 times. So I get negative 7/3. And 0 minus 1/3 is negative 1/3. That's the projection. That problem is done. Okay. Now, part B3. BIII. So, T is a mapping, a transformation from R3 to R3. And they tell us that T of vector V is equal to just what we did, the projection of V onto P. But they want to know what matrix will do this. Well, let us see. First, let us see what got erased here and why it was erased. Negative 1/3. Okay. But this time, I'll keep it as negative 2/6. That's going to be the matrix, but we can clean it up a little bit. You have negative 5 halves, positive 5 halves, negative 5 halves, and 0. If I multiply by 2, the 2's cancel, I get 5. The 2 cancels, I get negative 5. 2 times 0 is 0. This is going to be one vector in the matrix. And the other vector, well, we have 1, 6, 1, 6, negative 2, 6. Now, if I multiply this by 6, 6 times the 6 is 1, 6 times the 6 is 1, 6 times negative 2, 6 is negative 2. These two are going to do what we want. You let the matrix equal. Now, let us now divide by 5. This will just become 1, negative 1, and 0. Okay, so 1, negative 1, 0, 1, 1, negative 2. That's the matrix. That is the matrix. That is, T of V is the same thing as 1, 1, negative 1, 1, 0, negative 2 times V. Now, 502. Now, so T of V would be this times 502. Okay, so it's not the biggest a deal, I apologize. But M, those vectors should have been written horizontally. 1, 1, negative 2. So, if T was if V was 502, then I should get this matrix times 502. And what you will get, for example, will be 5, 1. Okay. And that finishes up problem number 2.